Hello everyone. Today we will talk about one of the market structures, perfect competition. So in microeconomics, we analyze specific sectors or industries according to the type of the market structure. So when we say market structure, we are making some observations about an industry or sector regarding how many sellers and buyers there are in that sector, how big they are, and how they make their decisions about profit maximization. So we will start with one ideal case. I say ideal case because if we would like to categorize market structure, you can think about a range of different market structure. At one end, this is where we start, we will have perfectly competitive market structures. And then at the other end of the spectrum, we will have market structures that are called monopolies. Right? And in between these two extreme cases of market structures, we will have other types, such as here we will have monopolistic competition. Monopolistic competition. Here we will have oligopoly. So at the end of this course, you'll understand characteristics of each of these different types of market structure and how we compare them in terms of the decision-making processes of the firms and the outcome when we talk about short-run equilibrium and long-run equilibrium. So we start with perfectly competitive markets because this is really a simplified case which we can use as a reference point to understand all these different market structures. So what types of markets we call perfectly competitive? This is where we are starting. And as you'll see in a moment, the assumptions we make to define a market as perfectly competitive are highly restrictive. Okay? What do I mean by restrictive? These assumptions we make to define a market as perfectly competitive market are really hard to find in real world. But they really help us to simplify, to see a simple model. And once we understand this, we can drop these unrealistic assumptions and understand other cases of market structure. That is why we are starting with this, okay? So what types of markets we call perfectly competitive markets? We have basically three conditions, okay? So these are characteristics of perfectly competitive markets. Okay, so one, we have many buyers and sellers. Okay, so in perfectly competitive markets, we have many buyers and sellers, okay? And there are so many sellers, we also imply, okay, I didn't write it here, but it is also important to remember each seller or buyer is relatively small to the size of the market, okay? They are small in the whole market. So later in this course, for instance, we will talk about oligopoly, okay? You might have many sellers in an oligopolistic market structure, but we will see one of these many sellers or several of these many sellers can be relatively big, right? In this example, we have so many sellers and they are each small relative to the market size, okay? That is our first condition. Now, second, in perfectly competitive markets, and this is a very restrictive assumption, we assume all sellers are selling an identical product, okay? Or we call this homogeneous products, okay? Okay, what do we mean by identical or homogeneous? So there are many sellers and consumers perceive the product, okay, sold by each of these sellers as exactly the same, okay? They don't see any difference between them. Now, this is very, very restrictive. Why? If you think about lots of industries, right, there might be many sellers. For instance, there might be many coffee sellers, right, coffee houses in Ankara. But you don't usually think they are selling exactly the same latte, right? You would say there are some differences in terms of the quality of service, in terms of the quality of the product. And in many markets, even when companies are selling very, very similar products, because in modern economies, advertisements is so important, right? We kind of might have a perception that these products are different just because of the brand name, right? So in those markets, for instance, later we will talk about monopolistic competition. In such a market structure, an important quality we will see is differentiated products, right? But in perfectly competitive markets, there is no differentiation. They are selling exactly the same thing. Now, as I said before, in reality, it is hard to find, but you can see markets that are they are very similar to this, right? That get close to perfectly competitive market structure. In markets where the goods are more or less generic, they are, for instance, agricultural produces or raw materials, okay? Think about the wheat market, right? Wheat, there are different types of wheat, but if we are talking about a specific type of wheat that are produced by hundreds of farmers, right? They would be probably the same. So raw materials or agricultural producers, sometimes you can find these characteristics. But as I said again, once we will start with these assumptions and then we will move on to other more realistic cases. Now, lastly, the third characteristics of perfectly competitive markets, there are no barriers to entry. There are no barriers to entry by definition, right? So these three is how we define perfectly competitive markets. There are no barriers to entry in perfectly competitive markets. What do we mean by entry? So in an industry or sector, when any potential firm who sees an opportunity of profit, right, positive economic profit, if they can easily enter into this sector, okay? So for instance, if we are talking about the coffee market in Ankara, right? And I see, okay, this is a good business. I would like to open a coffee house, and it is relatively easy. There is no one telling me, no, you cannot open a coffee house, you need a license, or you need I don't know, we only allow a certain amount of coffee makers in Ankara. They don't say it, right? So when we say barriers to entry, okay, we mean social, legal, or economic barriers that prevent potential entrepreneurs from entering into that business. When we are discussing monopolies and oligopolies usually exist because there are significant barriers to entry. So when we talk about them, we will explain in detail what these barriers to entry are, but a very popular example today, for instance, if Inesti There is a restriction about the number of taxi medallions, taxi plates, right? In Istanbul, you can only have 10,000 taxis driving around. Then that is an obvious barrier to entry, right? If the government says, I only allow one firm to provide electricity in Ankara, then that is a barrier to entry. Barriers to entry can be natural or legal, we will see. They can be bad or sometimes not so harmful, we will see. But in perfectly competitive markets, we have no barriers to entry. Okay. Because of these three characteristics, perfectly competitive markets have some specific features that will help us understand why firms behave the way they do, okay? So we will analyze firms' decision making, how they try to maximize their profit in a perfectly competitive market. And when they try to maximize their profit in a perfectly competitive market, what happens in the short run and in the long run? We will talk about it. But because of these characteristics, first, we will think about the first implication of these characteristics. So these are the implications, right? Because of these two things, okay, because there are many sellers and they are selling exactly the same thing, firms in perfectly competitive markets are price takers. Okay, one consequence. Firms are price takers. Firms are price takers. We can express this also as they have no market power, okay? So when we say firms are price takers, it also means firms in perfectly competitive markets have no market power. Again, later we will see firms here, here, and here. They have some sort of market power. They are price makers. What do we mean by price makers? They cannot choose any price they want, but they can have a strategy about the price that maximizes their profit, okay? Once you have some market power. But in perfectly competitive markets, no, you don't have such a strategy. Now let me explain why, because this is really, really important. Now, imagine a perfectly competitive market. Let's simplify it a little bit. We are talking about the bazaar in 100. Yıl, okay? And let's say there are 20 or 30 sellers of a certain type of tomato. And each tomato, we are assuming, okay? Let's make it a little bit restrictive. We are assuming each tomato, a specific type of tomato, Ayaş tomato, sold by these different sellers are perceived as the same by the consumers, right? So you as a consumer go to the bazaar and you see all these sellers, right? So what do? Usually you go around and check if there is anyone selling, especially if you think these tomatoes have the same quality. Usually in real life there are other things that affect you, right? Some of the sellers might be nicer or might, I don't know, you might prefer some tomato to the others even when it is slightly more expensive. But let's assume you are a rational being, right? And you think these tomatoes are the same. You should go around, right? And you would see all these people are selling these tomatoes at the same price. If not, right, you would go to the one who is selling the tomato at a lower price. That makes sense because they are all the same, right? So if this is, okay, this is market for Ayaş tomatoes, right? And I'm drawing right now the market demand and supply curves as we did in the previous lecture. This is for the market. So this is Demand for Ayash tomatoes, it is downward sloping as usual. Okay. And this is supply for Ayash tomatoes. We have price here, right? Market supply, market demand, and in a perfectly competitive market, equilibrium price is the price where quantity supplied is equal to quantity demand, right? We covered this before. So this is our equilibrium price. Now remember, if price is actually higher than this, there will be excess supply, price will go down. If price is lower than this, there will be excess demand, price will go up. So this is the equilibrium when there is no change. Now, here is the thing. I know that this is a perfectly competitive market, and I would like to sell also tomatoes in the bazaar. So I go look at the bazaar, and what I see, everyone is selling the tomatoes for 60 TL a kilogram, right? So in a perfectly competitive market, I should also sell my tomatoes at the same price, at the market price, because if not, I cannot sell any. Why I cannot sell any tomatoes if I decide to put a price higher than 6? Because this market, that is an information I have already given to you, right? This market is a perfectly competitive market, meaning you know that all these Ayash tomatoes are perceived as the same by the buyers, right? So if I go open a stand and I say, I'm selling this for 8 TL, nobody will come and purchase tomatoes from me, okay? There will be zero demand for my tomatoes. What about, like, if I try to compete with a price that is lower than 8, in a perfectly, 6, in a perfectly competitive market, and we will see more in a few minutes, but you can sell as much as you want. You can sell as much as you want at the equilibrium price, right? So if you choose to sell your tomatoes at the market price, 6, okay, you can sell as much as you want. So, like, reducing the price to 4 and selling as much as you want will not bring you extra profit. It doesn't make sense. So what I'm trying to say, you should stick with this price, no matter what. So this is now we will do something important. This is the industry demand curve or sector demand curve. Okay, so in macroeconomics, we are always talking about specific markets. This is for Ayash tomatoes in Ankara or in 100. Yıl, let's say. Now I want to draw, we will do this again for other types of firms. I want to draw a demand curve faced by the single seller, okay? So I'm this person A or B or Ali, whoever we are talking about. So this farmer, okay, I will draw the demand curve. Basically, I'm showing, okay, the relationship between price and quantity demanded for Ali, for the tomatoes produced by Ali, a specific person in this market. Okay, so basically I'm asking this: how many tomatoes how many tomatoes produced by Ali will be demanded at this price? What? How many? Nothing. Because if Ali chooses this price, which is higher than this market price, he cannot sell any, right? This is the same for here, 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 and for prices below here, they don't make sense. So the market price, equilibrium price, is the only price that there will be demand for Ali's tomatoes. Okay? We show this individual demand curve, demand for a specific person's tomatoes with little d. Okay? And we draw it in a perfectly competitive market. We draw the demand curve faced by Ali as horizontal. Okay, horizontal demand curves means that this demand is perfectly elastic. Perfectly elastic, right? I mean, if we have to express it with a number, it is approaching infinity. We talked about elasticities before. So the demand curve for an individual producer in a perfectly competitive market is perfectly elastic, which is the graphical representation of this idea. Firms in perfectly competitive markets are price takers. They have to accept this price. There is no other price that they can sell their goods for. Okay? So this is the individual demand curve. And this is what we mean by firms are price takers. Now, this will be very, very, very useful for us in to understand how firms maximize profit in a perfectly competitive market in a moment. But let me go to another characteristics in addition to this. Okay, so we know firms in perfectly competitive markets are price takers. There is something else that is important. Because there are no barriers to entry, okay, this is the second implication of a perfectly competitive market. Firms in perfectly competitive markets, make zero economic profit in the long run. Okay, let me repeat this. Firms in perfectly competitive markets make zero economic profit in the long run. So let's remember the distinction between short run. Okay, let me go here. Let's think about the relationship between short run and long run. Okay, in the short run, okay, we talked about in the short run there is a fixed input. In the long run there are no fixed inputs. But this is not about it. There is something else. Actually, it is about it. So, in the short run, we take the number of firms as given. Okay? The number of firms in a specific market cannot change in the short run. That is the definition of short run. But they can change the quantity they produce. They can increase the output or they can decrease the output in the short run. How? By changing the amount of variable input. They cannot change the amount of fixed input, but they can change the amount of variable input and they can increase output or decrease output. Okay, that is the short run decision. So for firms in perfectly competitive markets, the short run decision is about the quantity. What is the quantity that maximizes profit? They have no decision about price. Why not? Because they are price takers. So they ask themselves, short run decision, they ask themselves about quantity that maximizes profit. Okay? Now, in the long run, here is the thing, they can change scale, yes, but let's put that aside. There is something else. Let's say in the short run, a firm is making a loss. It is possible, we will see. a firm might be making a loss in the short run. So this firm might decide not to produce anything in the short run, yes, or to produce something, but in the long run, it has another decision to make. Enter, or actually for a firm that is already in the industry, exit. Okay. So entering or exiting, as defined by this course, is a decision that firms can make only in the long run. Why? Because let's say I'm making a loss, okay? If I'm making a loss, it makes more sense to just quit it, right? To just shut it down. Now, because we made that assumption, there is a fixed input. For instance, I'm a restaurant owner. I rented a place for a year, okay, for a year. And I'm making a loss, but that demand curve for an individual producer in a perfectly competitive market is perfectly elastic, which is the graphical representation of this idea. Firms in perfectly competitive markets are price takers. They have to accept this price. There is no other price that they can sell their goods for, okay? So this is the individual demand curve. And this is what we mean by firms are price takers. Now, this will be very, very, very useful for us to understand how firms maximize profit in a perfectly competitive market in a moment. But let me go to another characteristics in addition to this. Okay, so we know firms in perfectly competitive markets are price takers. There is something else that is important. Because there are no barriers to entry, okay, this is the second implication of a perfectly competitive market. Firms in perfectly competitive markets, make zero economic profit in the long run. Okay, let me repeat this. Firms in perfectly competitive markets make zero economic profit in the long run. So let's remember the distinction between short run. Okay, let me go here. Let's think about the relationship between short run and long run. Okay, in the short run, okay, we talked about in the short run there is a fixed input. In the long run there are no fixed inputs. But this is not about it. There is something else. Actually, it is about it. So, in the short run, we take the number of firms as given. Okay? The number of firms in a specific market cannot change in the short run. That is the definition of short run. But they can change the quantity they produce. They can increase the output or they can decrease the output in the short run. How? By changing the amount of variable input. They cannot change the amount of fixed input, but they can change the amount of variable input and they can increase output or decrease output. Okay, that is the short run decision. So for firms in perfectly competitive markets, the short run decision is about the quantity. What is the quantity that maximizes profit? They have no decision about price. Why not? Because they are price takers. So they ask themselves, short run decision, they ask themselves about quantity that maximizes profit. Okay? Now, in the long run, here is the thing. they can change scale, yes, but let's put that aside. There is something else. Let's say in the short run, a firm is making a loss. It is possible, we will see. A firm might be making a loss in the short run. So, this firm might decide not to produce anything in the short run, yes, or to produce something, but in the long run, it has another decision to make. Enter, or actually for a firm that is already in the industry, exit. Okay. So entering or exiting, as defined by this course, is a decision that firms can make only in the long run. Why? Because let's say I'm making a loss, okay? If I'm making a loss, it makes more sense to just quit it, right? To just shut it down. Now, because we made that assumption, there is a fixed input. For instance, I'm a restaurant owner. I rented a place for a year, okay, for a year. And I'm making a loss, but that place, the place I rented, I cannot terminate the rental contract immediately. So even if I decide to produce nothing, I will continue to pay for the rent at least for a few months more. Okay? So in the short run, I cannot get rid of all inputs. There is at least one fixed input. Okay? Only in the long run, I can say, if I'm making a loss, I can say, hey, I'm exiting. So exit, by definition, okay, exit is getting rid of all inputs. So there is no fixed input in the long run. So you just get rid of everything. You are not in business anymore. This is something, according to us, you can only do in the long run. You cannot do this in the short run. In the long run, the other thing, let's say there are many firms in a specific market, perfectly competitive market, like Ayaş tomato market. And all these tomato sellers, let's say, are making positive economic profit. Okay, they are making a profit. And there are other people who are in other businesses. Okay, so I see this. I'm an outsider. I'm not in this market. So I say, oh, this is a good business. And in the long run, I might decide, and I cannot just decide tomorrow I will take my tomatoes to the market. It will take time for me to find the necessary inputs. It means in the long run, we can enter into a market, right? So entering and exiting are long run decisions. And in a market where there are no barriers to entry, when there are positive economic profits, more firms will enter. And because more firms will enter, profits will go down to zero. We will explain this with a graph soon in the next lecture. When there are losses made by each firm, then these firms are not happy, and in the long run, they will exit. When some of the firms exit, because they exit, the losses will disappear, and we will see why. Only when economic profits are zero, okay, I hope you can read this. Only when economic profits are zero, there will be no entry or exit. So this is our long-run equilibrium. No entry or no exit when economic profits are zero. You might say, this is weird. Why there would be any sector with zero economic profit? Now remember the definition of economic profit. Economic profit is not the same as accounting profit. Right? Economic profit is defined as total revenue minus total economic cost. And total economic cost includes both accounting cost, which is also known as explicit cost, and implicit cost, which is also known as opportunity cost. So basically, if you are making a zero economic profit, your total revenue covers your accounting costs, yes. Okay, you are basically covering all your accounting explicit costs, plus your opportunity cost, which means in this business, you are making a profit, an accounting profit, that is at least as good as you would do in the second best alternative, right? Usually that second best alternative is defined as depositing your money in the bank. So when we say zero economic profit, what it means? I'm covering my accounting cost. I'm also earning as much as I would if I deposited my money in the bank instead of, starting this business. If I put that money in the bank and got a return as interest rate, so I'm at least making that money. So this is not awful, okay? You are earning something here when we say economic profit is zero. So this is short run, long run, okay. Now we will see some really nice graphs and some numerical examples, but to understand those graphs and numerical examples, we need to remember the definition of profit. The definition of profit doesn't change for any firm. Any firm here, 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 they have the same definition of profit, which is, okay, maybe I use something else here. Okay, good. Profit is total revenue minus total cost. Okay, this is the definition of profit. Now, our assumption in this market and in this course, right? This is an introductory course. Firms are maximizing their profit. That is their intention. In real life, if you take more advanced courses in economics or in business administration, you might see sometimes firms might try to do other things rather than maximizing profit. But nevertheless, profit is really important, right? So how do firms make this decision? Now we will start with perfectly competitive markets, but I want you to remember this. And remember also total revenue, again, in our simple model, the only revenue that firm gets is from selling the goods it produces. Okay? Selling the good it produces. So total revenue by definition is price times quantity sold. Price times quantity sold. That is total revenue. Okay? Minus total cost. And total cost, remember, in the previous lecture, we saw the shapes of cost curves and production curves and how they are related. These cost functions are functions of output, right? When I produce something, right, as I produce more, I don't know, sandwiches, coffee, whatever we are talking about, my cost will go up. Why? I will use more labor. I will use more capital. I have to make more expenditure to produce more. So here we have something that depends on output, and here we have also something that depends on output. So both sides of this definition depends on output, okay? So here is the thing. I'm asking, in perfectly competitive markets, this is given. It's coming from here. I know what it is. It is a number, a constant number, okay? That comes from demand and supply functions. In a question, in a problem, there would be an equation for this, an equation for supply, and you can solve those equations to find this number, which as a firm, I have to take as given. Now I'm asking myself this, what is the quantity that maximizes this profit, right? So each quantity will add to my total revenue. When I sell more, I will get more. Why? I'm selling, I'm earning something. But when I sell more, it means I'm producing more, so I'm spending more. So I'm actually, to make a rational decision, I have to compare how much that production contributes to my revenue and to my cost. Okay? Basically, I have to compare two things. How much my total revenue changes, increases, in response to a change in quantity. Okay? So, this is change in total revenue divided by change in quantity. Okay? This is, if we draw a total revenue curve, this would be the derivative of that curve, right? So how much my total revenue changes when I increase output by 1, from 2 to 3, from 3 to 4, from 4 to 5, and then I want to compare this with total cost, change in total cost, divided by change in quantity. Now, change in total cost divided by change in quantity. What is this? We have already covered this. This is, again, definitionally marginal cost, the derivative of total cost. Okay? So we are looking at, basically, we are looking at the relationship between marginal revenue and marginal cost. We are looking at the relationship between marginal revenue and marginal cost. Remember, in the very beginning of this course, when we were talking about what economics is about, economic analysis is about, we said it is about the calculations of benefits and costs at the margin, right? So that's a perfect example of this. So for any firm, I'm not only talking about perfectly competitive firms. For any firm, they are actually making a comparison between marginal revenue and marginal cost. So here is a general rule. As long as for an output, the marginal revenue of that output is higher than marginal cost of that output, the firm will choose to produce that output. Because when marginal revenue is more than marginal cost, profit would be increasing. Producing that output makes sense. If marginal cost is more than marginal revenue for a certain output, then producing that output doesn't make sense, because when marginal cost is more than marginal revenue, our profit will be declining. What are we trying to do? Maximize profit. So produce as long as marginal revenue is more than marginal cost. And do not produce when marginal revenue is less than marginal cost. So on a graph, you will see this will mean we will produce up to a point when marginal revenue is equal to marginal cost. This is the profit maximizing rule. When we are using numeric examples with discrete numbers, you cannot find this exact point. So I want you to understand the logic behind this. We want to produce as long as additional revenue from an additional quantity, which is marginal revenue, is more than additional cost from producing an additional output, which is marginal cost. And then stop when marginal cost becomes larger than marginal revenue. This is a very general, meaning generalizable for all firms, profit maximizing rule. Now we will see what happens in a perfectly competitive market when the firm applies this rule, okay? With a numeric example that is coming up next. Okay, now with this example, we will see how this rule, marginal revenue is equal to marginal cost, makes sense for a profit maximizing firm in a perfectly competitive market. Okay, we will try to see a numerical example. So let's look at the numbers first to understand these are really representative of a standard firm in a perfectly competitive market. Now, the price of the good, as we said, firms in perfectly competitive markets are price takers. So here on this column, we have 5. You might ask, where does this 5 come from? From the market demand and supply, okay? So firm can sell its produce, can sell 2, 3, or whatever the quantity it prefers to sell at this price. It has no effect on the price. That's why we have the same number here. This is representing the perfectly elastic demand curve for the firm. Okay? Now, these are different quantities for the firm. So our question is, what is the quantity among this that maximizes profit for this firm? Okay? Is it like 2, 3, 4, 5, which one? So total revenue by definition is price times quantity, right? So the numbers here, I didn't have to give to you on this graph. If you are given price and quantity, you can write down quantities and you can find total revenue yourself, right? So total revenue, 5 times 0, because it is selling nothing, total revenue is 0. 5 times 1, 5. 5 times 2, 10. 5 times 3, 15, and it goes like this, right? So I will not draw this, but I want you to imagine how does a total revenue curve look like on a graph, okay? Just as an exercise, you can imagine quantity on the horizontal axis and revenue and costs, monetary value on the vertical axis, right? You can draw a graph. And then what is the shape of this total revenue curve? That's the question for you. Let me give you a tip. Total revenue for this particular price, if I write it as a function, it is 5 times Q, right? So total revenue is 5 times Q. Because this is price, this is constant. 5 times Q will give us total revenue. Now, what is marginal revenue? Marginal revenue, by definition, is the change in total revenue in response to a change in quantity. So we always show marginal revenues for this. So when I increase output by 1, what is the change in total revenue? When I increase output from 1 to 2, what is the change in total revenue? What is the change? Here. Now. Okay. So what can we say about marginal revenue? Marginal revenue is constant and it is equal to price, right? You can show it by using derivative, very simple calculus to find marginal revenue here. Marginal revenue is the derivative of total revenue with respect to Q. So it is this number here, coefficient of Q, right? So marginal revenue is 5, which is equal to price. You'll see later this marginal revenue being equal to price is not true for firms in other types of market, okay? This is something specific to the firms in perfectly competitive markets because they are price takers, okay? That is very important. Now let's come to the costs. So I know marginal revenue. I want to focus on the costs. So in this example, total fixed cost is 2. And it is 2 for any number of quantity, which makes sense because total fixed cost is the cost of fixed input. It is supposed to not change, right? So if I had a number that varies here, changing here, then it wouldn't make sense. So this is the cost of fixed input. And I tell you that it is 2. okay, in this example. Total variable cost is going up, and it is going up at an increasing rate. In reality, marginal cost, so let me say it this way, total cost first goes up at a decreasing rate, then at an increasing rate, but it doesn't really matter. In this example, total cost is going up. And the change in total cost with respect to change in quantity is increasing. How do I know? So, okay, total variable cost is increasing. How did I find total cost? By definition, it is total fixed cost plus total variable cost. Okay? So I wrote these numbers. 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 4 is 6. So these are the summations. Now, I gave these numbers to you, okay, in a way that will make the marginal cost look like a standard marginal cost curve, okay? But sometimes in examples we use different types of marginal cost curves as well. What is the definition of marginal cost? The change in total cost or change in total variable cost with respect to a change in Q, okay? So when I increase quantity from 0 to 1, what is the change in total cost? It is the same as change in total variable cost, by the way, because the only change in total cost comes from this component. This component of total cost is fixed. So you would find the same number if you just look at the changes here. Okay, here, 1, 3, 4, 6, and 8. A marginal cost that is going up. Okay. Now let's do this. Now I have these numbers as the firm's manager. I want to maximize profit. I can do it two ways, and I want you to understand both. That's why I wrote marginal revenue, okay, which is constant, and marginal cost, which is an increasing number. Now, let's forget about marginal revenue and marginal cost and look at the standard definition of profit, which is total revenue minus total cost. So I can write profit by looking at total revenue minus total cost. So these two columns, okay? 0 minus 2, minus 2, okay? 5 minus 3. So if I produce this first output, okay, what is my profit? 5 minus 3 is 2. If I produce this output, what is my profit? 10 minus 6 is 4. If I produce this one, 15 minus 10 is 5. 20 minus 16 is 4. 25, right, minus 24 is 1. Okay. So for each amount of output quantity, I can find profit because I know total revenue and total cost. So what is the profit maximizing quantity? Just look at this, which is the maximum profit? 5. Okay, so profit maximizing quantity would be 3, right? 3 is the profit maximizing quantity. But from this table, I also want you to see something else. As long as marginal revenue is more than marginal cost, 5 is more than 1, my profit is increasing. Why? Producing this adds more to my revenue than to my cost. Producing the second, let's look at the quantity 2. Marginal revenue, 5, is more than 3. So producing the second output increases my profit. Increases my profit because producing this adds more to my total revenue than to my total cost, right? So I'm comparing, now I'm doing the same exercise by looking at marginal revenue and marginal cost. Now come here, now look at this, marginal cost for the fifth output. Marginal cost is 6, marginal revenue is 5. This means if I produce this, okay, sorry, this fourth item, it will add more to my cost than to my revenue. This doesn't make sense, okay? So actually the rule that says produce as long as marginal revenue is more than marginal cost tells me to stop here. Here, exactly here, right? So we have to stop. Marginal revenue is more than marginal cost. So shall I produce this third quantity? Yes. But stop there. Don't produce this because now marginal revenue is less than marginal cost. So basically we are using that rule even though in this numerical example there is no point where marginal revenue is exactly equal to marginal cost. There is no 5 years on this column, no 5. So you cannot find a point where MR is equal to MC, right? But the logic of the rule is there. You should produce up until as long as marginal revenue is more than marginal cost and stop when it is not. So this is our profit maximizing quantity. So we actually show that this idea of marginal revenue and marginal cost, comparing them really makes sense. We see it because profit goes up, then it starts going down. If we would like to show it on a graph, and then we will stop, we will show all this on a graph. Okay, now we would like to represent a standard firm's profit making on a graph in a perfectly competitive market, okay? Now remember this curve. Price is constant because this firm is price taker, okay? Let's say this price is any number. In this example, it's 5, right? Now this price is 5, okay? For this firm, because it is a price taker, marginal revenue is also 5. Marginal revenue is also 5. So this perfectly elastic demand curve, okay, also represents marginal revenue curve because marginal revenue is equal to price, which is a constant number, okay? And also, one additional information, think about the definition of average revenue. Total revenue divided by Q. Average is always defined by dividing Q, right? So when we find average total cost, it is total cost divided by Q. When we define average revenue, okay, this is true always, average revenue is total revenue divided by Q, then it would be equal to, again, 5, right? So this curve is also average revenue. So this straight curve, we have here anything, cost, price, total revenue, revenues. This is a monetary value which shows us our costs and revenues or prices, right? And this is the quantity. So our marginal revenue doesn't depend on quantity. That is what it means. Our price doesn't depend on quantity. Average revenue doesn't depend on quantity. This is our marginal revenue curve, okay? For a regular firm, marginal cost curve first decreases, then increases. Sometimes, depending on the equation, we only represent an upward sloping curve. That's fine. Usually it's upward sloping, right? So I'm drawing a standard marginal cost curve. Okay. So this marginal cost looks like this, only it doesn't have this part. It doesn't matter really. We have an upward sloping marginal cost curve, okay? So here is our profit maximizing rule. What our profit maximizing rule tells us. As long as marginal revenue is more than marginal cost. So, okay, there is a certain amount of quantity here. And I'm asking myself, shall I produce this thing? For instance, our second sandwich. Yes, if marginal revenue is more than marginal cost, yes. And then what about this one? Marginal revenue, this big, right? And then this is my marginal cost. Yes, produce that. Produce up until here. Okay, what is this Q star? Profit maximizing quantity. This is how we find and show profit maximizing quantity on a graph with marginal revenue curve and marginal cost curve. You find the point that marginal revenue intersects marginal cost. And you say, this is our profit maximizing quantity. Any point to the right of this, right, to this direction. Now, if you go here, you don't produce here because marginal cost is more than marginal revenue. This will reduce my profit, right? So I stop here. This is my profit maximizing quantity, okay? Now, how do I show the amount of profit on this graph? Never say that you show it by these areas. It doesn't work that way. We will show it by using, you need only one more curve here on this graph to show the amount of profit on this graph, okay? So I want you to remember the definition of profit once more. Price times quantity minus total cost. That is the definition. I can write this as this. I will read it. If you have difficulty seeing, I will also read it. Okay, look at this. Profit is equal to price times quantity minus total cost. I can write this in parentheses of quantity. So you see it here, right? Price times quantity we will have here. And once you multiply quantity with average total cost, you will find total cost. Why? Average total cost, by definition, is equal to total cost divided by quantity. So this is same as the second line. Quantity times, in parentheses, price minus average total cost. We have price on this curve. Price, which is also average revenue, right? We only need average total cost curve. So once, okay, here is what we do. On a graph, to show the profit maximizing quantity, this is true for any firm, if you have these curves though. As we will see later, you cannot have these curves for firms in some market structures. But if you have marginal cost curve and if you have marginal revenue curve, you find their intersection point to find profit maximizing quantity, okay? And then at that quantity, you ask yourself this: what is average total cost at that quantity? What is price at that quantity? Price is given. So if I know average total cost, I'm making you a nice U-shaped average total cost. It should be U-shaped. It should be U-shaped. And it should intersect marginal cost at it is at, so let me repeat this. Marginal cost should intersect average total cost at its minimum. Why? Because of the mathematical relationship I talked about in one of the previous lectures. We know, and we talked about the shapes of marginal cost curves and average total cost curves. This is a nice looking average total cost curve. And this is where it intersects marginal cost. But this doesn't matter for us now. This is where I want to mark. What is this? What I'm asking myself this question. What is the average total cost if I produce this quantity? You go up from the quantity to the average total cost curve. Okay, this will, see this number. This will give you average total cost at this quantity. Okay. So this area, this rectangular here, average total cost times quantity. Average total cost times quantity. This rectangular here will give me total cost. Price times quantity. Where's my quantity? Here. Don't go here. Okay, don't forget. Your profit maximizing quantity is where marginal revenue intersects marginal cost. It is here. So this quantity times what? Price. So this large rectangular here is total revenue. So I have total revenue here and total cost here with the small rectangular. So the difference, the nice difference on this graph, which represents profit, okay. Do you see that rectangular? The difference between larger rectangular and smaller rectangular. That difference on the graph shows me the profit of this firm. Now we will stop here, but we will continue working on several graphs where we show firms making profit, firms making loss, firms making zero economic profit in the long run, and how we link short run to long run. Okay.